today we are discussing the command pattern. So what is the basic premise of it? To encapsulate a request as an object. So concentrate on the word request. So the idea of a request could be an input, it could be an event, it could be basically anything. In context of Unity, we can treat them as Unity events or basically anything and any kind of event that happens. The second word is an object. So we need to encapsulate a request and create an object out of it. So object, for a class we have instances which we call as objects. So this is the same concept. And here the class would be a command. So it could be an interface also. So the object can be passed around. So by pass around, we can pass it through a collection object as a stack or a queue, or we can pass it around between different objects, and then we can execute them as and when we need them. So basically we are not bounded to execute the event whenever the request is there. We can execute it as and when we need, as and when our collection is used. Now we can see what are the components of a command pattern. First, we have the command itself. So by command, I mean two things. First is the interface of command. We should be having at least one and mostly two methods. First is execute. It could be named differently, but it basically states what we want the action to be. And the second one is mostly undo or unexecute, which is the reverse of that action. And then the second thing that we want is a concrete implementation of it, which could be used as a command. So second, we have an invoker. So you can think of it as something which triggers that event. It could be an event, it could be an input, it could be anything. Then we have a receiver. So receiver, you can think of a class or an instance which receives that invoker event and then executes the command itself. So basically we are passing the command to the receiver on this invoker being called. Flexibility. So as commands can be easily swapped in or swapped out without modifying the whole thing itself, this gives us a lot of flexibility. We can have a particular command in a stack, and then we can swap out some elements of it, and just because it has to adhere to a particular thing which is interface pattern, then we can easily change it around. And as we can store it in a stack, and hence on popping it and executing the command, we can get the undo pattern itself. So it's kind of a free gift for us if we are able to use it in a proper manner. If we are using a stack for recording, then we get undo functionality for almost free. If we are using a queue and run that queue again, we'll get the whole thing executed again, which will give us kind of a macro functionality itself. So it depends on your implementation. If you want undo functionality prominent, you can use a stack. If you want macro recordings prominent, you can use a queue, or something like I did, use list and get the functionality of both worlds. So for example one, I have created a very basic setup. We can spawn some cubes. I have added 3 commands which spawn a red, blue and green cube with W, A and D key. So I'll show you that. So this is A key, this is W, this is D. Now I can add them anywhere where I want, right? And this gets spawned. And because these are commands, I can create them as a stack, and then I get the free functionality of undo. So if I press S key, you'll see I can undo the whole thing that I created. This is just a simple example of adding instantiation as a command, right? So this could be anything. Even we can have some particle effects if we want to have some kind of splitting in between the cubes, or basically anything that your team wants. You can have that as a command, and if you store that as a stack, you can basically have the undo functionality. Extending upon the previous example, I'll demonstrate how we can have a command stack as a command itself. So now I'll create, let's say, these 4 cubes, right? And I like the way they are oriented. I like the thing. I want to have this as a command itself. If I press one button, this should happen. So what I can do is I can copy that particular stack and store it into another stack. And so if I press 1 in this particular example, this is how I set it up. You can obviously have a different setup. I pressed 1 and now we have copied the stack on another stack. That command stack as a command is 2. So I'll press 2 and you'll see we are instantiating that same sequence in a different location. This is getting stored as a command itself. So now you can see that all these things I'm able to basically combine all the concepts of command pattern and of treating that input as a command itself, basically creating that as an object. Now that object could be used in any way that you want. So now we can walk through the code. Basically we are having an interface for command. So now you see that we have execute and unexecute, very generic methods. Execute basically adds the functionality that we want to add, and unexecute is removing that functionality, so as an undo. And in build command we are implementing that interface with some properties that I want to store. Let's say building reference, position, rotation, offset, and some basic methods. Here in the execute I'm instantiating it, and in unexecute I'm destroying that object. Now for the command stack. So command stack is nothing but that collection that I want to have for commands, so that I can undo and I can contain a whole history of it. And even if I want, I can add the redo functionality with this. So this could obviously be a stack, a queue, a list, and basically it depends on your use case. So yeah, some basic functionality of clone, push, clear stack, and get count and everything. Now we get to the commander class. So commander class basically gets the input and invoke the commands. So all the commands that I'm getting, I'm pushing, undoing, popping, and everything, that is getting controlled. So you can think of it as a manager class. Now we have input manager, so all the W, A, S, D keys, alphabet 1, alphabet 2, I'm using here. Obviously with your implementation you can have different kind of setups, but for a basic tutorial I have implemented it in this way. And then we have the raycaster, so basically raycasting that mouse click and getting that position, simple stuff. All this code would be attached to the GitHub repo, link would be in the description. Now we can talk about some extensions of the command pattern. First, it is very generic. So as we have seen, it just have two methods, which is execute and unexecute. So as it is quite generic, it can absolutely encapsulate any kind of actions that you want. So it could be spawning something, some movement input, or basically any kind of thing. Which leads us to the recording system. As you might have seen in games like CSGO, so they have a recording system in which they have all the inputs as command, and then they can store that, and now it can be seen by anyone. So that is something that could also be implemented with command pattern. Obviously there would be much more modifications, but those can be taken care as and when we are working on that. One example of stacks as a command I've already shown, but this is a very powerful concept and could be extended to any length. Then we can have as many things as we want because of the generic nature of this pattern. It could be used in many places.
Why does it sound like encapsulation with extra steps?
Actually, no, sure. It's not just polymorphism. We are having some other things also implemented in this. So basically the idea of command pattern is using polymorphism with some emphasis on encapsulation, decoupling, and flexibility. So the flexibility that we are getting, the decoupling of requests from the objects, and the encapsulation of that request is what is the main crux of a command. Now obviously the main idea could also be implemented with just polymorphism, but that decoupling part could be a bit hard to achieve without that command pattern. And as always, thank you so much for watching.